Good morning, students. As you know, we are discussing about that is practice set 3.4. Practice set 3.4 that day we start, and from that exercise, I remember question number 1 we completed, question number 2 we did half only. So that part we will continue. Question number 2, look at here. It's related to your cyclic quadrilateral concept. This is the PQRS. It is a cyclic quadrilateral. Angle PSR is 110 degree, and more things are there. Which one here? Segment side PQ and side QR. It's a congruent, and then find the value. So I think so in the previous session we discussed about the half part. Today I'll start again. So as it given by them, ki quadrilateral PQRS is a cyclic quadrilateral. This is given, and in this cyclic quadrilateral, angle S is here 110. Angle S is 110. So immediately we have to find what is the measure of angle PQR. We know the property, the opposite angles of cyclic quadrilateral are what? Opposite angles of cyclic quadrilateral are supplementary. That we discussed in the last here session only. So according to the concept, we can write ki angle S plus angle Q, which is equals to 180 degree. The reason we will write, what is that? It's opposite angles of, this is cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are what? So they are 180, otherwise you can write as they are supplementary, and substitute the value. Angle S is 110 degree, angle Q we have to find, which is equals to 180. So that's why angle Q, which is equals to, this is 180 minus 110 degree. So angle Q's measure here we got how much it is. So that is 70 degree. You can see the diagram, angle Q. So here we have angle Q is how much are there? So that we get, it's a 70 degree. After getting the angle Q's measure, immediately we will discuss which is given by them. So this is PQ. Here we will write segment PQ, which is congruent to the next segment. Next segment we have, that is QR. This is the numbers we didn't put, I'll write it. This is the first one, and here we'll write second. So this is given only. What it happened in this triangle, in triangle PQR, segment PQ and segment QR, these are the congruent segment and they are congruent to each other. Then later what we have to find the remaining values also now. So by using this given concept, what we are going to do, we will find their opposite angles. So that was last year theorem, which is an isosceles. If the two sides are congruent, their opposite angles also will be congruent. So according to the theorems, here you will come to know that angle, which angle? RPQ. Angle RPQ, which is congruent to the next angle, here you are going to get, that is the PRQ. Write it here. This is the statement number 3, and what we can write it? It is, see, you can write isosceles triangle theorem also, otherwise opposite side. So I feel that I am writing here isosceles triangle theorem. So by the isosceles triangle theorem, what it happens, we come to know when two sides are congruent or equal, their opposite angles also equal or congruent. So let's see, here we showed this and this two angles, they are congruent. We don't know the measurement, just will consider suppose XA. So that's why here we will write, let measure of angle RPQ, which is equals to measure of angle PRQ, which is equals to X degree. So X degree is the measurement, and we will use the angle addition property. Therefore down X degree plus which it is. So here 70 means, otherwise I will write it directly, instead of substituting the value I will write therefore now in triangle, which it is. So that is PQR. In triangle PQR, what we are doing, we are going to apply the angle addition property. So angle which it is, angle RPQ plus angle PRQ plus angle, next is PQR, which is equals to how much we are going to get, 180 degree. It's an angle addition property, angle addition property of a triangle, that it will be. And so then substitute the value which we guessed with the help of the given and isosceles triangle theorem. We come to know that ki angle P vertex, that is x degree we guess, and this is also x. This is PQR, we find it with the concept of which it is opposite angle of a cyclic quadrilateral, which is equals to here now 180 degree. And so here let's see x plus x, that is 2x, equation in one variable will be formed, which is equals to 180 minus 70 degree. It means the value of a 2x which is equals to 110. 110 means therefore value of x is equals to 255 110. So x is 55, x means which it is, I will substitute here this value. So this will be 55 and this also will be 55. So down we are going to write, therefore here measure of angle, that is RPQ, which is equals to measure of angle PRQ, which is equals to x we guess, and here we got that is 55 degree. So we find it this and that angles measure, for it will keep, this is the statement number 3. After writing this, we will turn to the topic ki what we have to find. Okay, they asked here find measure of angle PRQ. So PRQ already we find it here, see we got it. Now arcs topic, find measure of arc PQR, first one. Where is PQR? Here it is, PQR. So PQR if you want to find, you can see here which angle is inscribed in them. So that is here PRQ. So first one, see, with the help of the given concept we will find the arcs value. So first it is we will find that is the PQ, and then we will find later that is QR. Okay. So look at here, otherwise simply think, see PQR, so you can consider this inscribed angle also, that is better instead of. So see here what we are going to get, this much part which I colored here till this point. Angle we have, this is angle PSR which is intercepted the arc which it is, so PQR. So that's why here we will write which the measure of angle, otherwise angle directly see you can find in the another way. Another means what? Angle is, here we realize angle PSR is an inscribed angle. PSR is an inscribed angle, and which one? PQR. This is PQR is the intercepted arc. So inscribed angle is what? Is half of to the intercepted arc, and intercepted arc is twice to the inscribed angle. We can find it measure of arc, which it is PQR, this value PQR, which is equals to 2 times 2 measure of which angle, so that is PSR. Here this is the fourth one, reason we can write it is the inscribed angle theorem. By the inscribed angle theorem, what will come to know? Measure of angle PRQ's value. So that will be what? This is 2 into PSR is given 110, so this is 110 degree, so which is equals to 220 degree. This is the fifth one. See here, we find it the measure of angle PQR. So PQR we got, that is 220 degree. Now let's see the next one. We have to find measure of QR's measure also. This one, what is the measure of RQR? Same thing, QR is intercepted by which angle? So here we have, that is inscribed angle PRQ. So down measure of arc which it is, so that is PQ, which is equal to twice to measure of angle, that is PRQ. Reason is inscribed angle theorem. This is the inscribed angle theorem, that's why. And so which is equals to 2 into PRQ is 55 degree here, so we will write it 55, which is equals to 110 degree. So see the next one, arc PQ we got, that is 110. Then later we have to find measure of arc QR also. Simple thing, the total here arc is 220, we find it 220 and this is what 110. So obviously next one, measure of arc. If you want to find C, QR also you can find in the another. There are lots of options for you. You can use the inscribed angle, you can use the angle addition property also. So suppose if you want to find arc, measure of arc which it is QR. QR is equals to also same 2 times to which whom it is to angle. We can write it RPQ. This is RPQ, same thing, that is also inscribed angle. Otherwise just now I told ki that one concept you can do by the arc addition property, because total arcs value we know that is 220, half part is 110, remaining also obviously it will be 110 only. Okay, so this was the question number which it is 2. Now I will discuss the next one, that is question number 3. It is related, important topics are there, that is also see question number 3. You will see it is also important, which we discussed already in standard 8. In standard 8 also these types of the questions were given. Just now again we will revise ourselves with this one concept. See what are here, they said MR and P, important are 2 marks question A. Question number 3 here, quadrilateral MRPN is a cyclic quadrilateral. Just I will construct the diagram, rough figure here. We will consider this is a cyclic quadrilateral, and in this cyclic quadrilateral, the name of cyclic quadrilateral is this is MRPN. MRPN is a cyclic quadrilateral, and in it angle R's measure is given 5x. This is 5x minus 13 degree, and next is what, angle N. Angle N's measure is given 4x plus 4 degree. So these are the angles measure, then find the measure of angle R and N. Important question, I told you just now, same question if we will see little bit, maybe ABCD or what last year in standard 8 we discussed. There also this topic were there. For finding the angle R's, if we will see already the measurements are given in equation in one variable. So obviously it will be solved in the concept of the equation in one variable. At the starting we can mention quadrilateral MRPN is a cyclic quadrilateral. This is the first one and we can write it's given. Quadrilateral MRPN is a cyclic quadrilateral. So we know that ki opposite angles. So we will write it angle R plus angle N, which is equals to 180. You can write it, this is the opposite angles of what? Cyclic quadrilateral. R what? So that is supplementary. In the previous example I mentioned the 180, the meaning is same only, that we have to write ki 180 or supplementary, means sum of the two angles addition is 180, supplementary we can say. Now substitute the value. Angle R's measure is given, that is 5x minus 13 degree, plus angle N is given, that is 4x plus 4, which is equals to here 180. We can say that to substituting the values here. The values we substituted, and now after see this is the equation in one variable, 5 plus 4, that is 9x. Here also plus minus 13 minus 4, so that is minus 9, which is equals to 180, and so here 9x which is equals to 180 plus 9 will become, so value of x which is equals to here 189. And so then we can say ki value of x is equals to 9 2s are 18, 9 1s are 9. So x is equals to how much we got? That is 21. For it we'll write its statement number 1. In the variables value find it. Now we will find angle R's measure. It's written, find the angle R and N. So here therefore here we'll write angle R is equals to, what is angle R's measure? It's a 5x minus 13 degree. This is written. The value of x we got, that is 21. We will substitute here. Therefore here angle R which is equals to 5 into x is 21, will write 21 minus this is 13 degree, and now give the lowest term. So 5 1s are 5, 5 2s are 10, 105 minus 13. Let's see how much it will be. So simple thing it is, 5 minus 3, this is 2, 10 minus 1 9, 92 degree. Angle R is 92. If you want to find angle n's major, so simple it is. Angle n is equals to, simply we can do it 180 degree minus 92 degree. Concept we apply, opposite angles of a cyclic quadrilateral are supplementary, that one. So angle r's major, how much you are going to get? So that will be, this is 0 means 7, so 8, 8 and then 17 minus, so how much it will be? 8 I think so, 88 degree. 10 carry 1, yes. So how much is that? This is the 2 marks question. Angle R is 92 degree, angle R is here 92 degree, and this is the angle N. This is the angle N. See now, opposite concept we apply, because angle R plus angle N, which is equals to what? 180. By using the concept, if we get angle R, we substitute it in them, so we can get the value of that one. Now after this, question number 4 we'll see. So it is also important. Actually what it happened after this, all the part, means after this exercise, whole the part is omitted. So that's why I am explaining these examples. Be carefully just now. Okay. So let's see. Here is the question number 4. In it what are written? So simply here they gave us one circle. Here we have, I'll write it the solution for it. This is the circle which is drawn the center O. Here we'll write this O is the center. This is R point. Here it is S point. And point T is the exterior, like this way. I'll just read, and then afterwards I'll write what is given to prove and prove, and then concept. See, they said segment RS is the diameter of a circle with the center O. Point T lies in the exterior of a circle. Then to prove angle RTS is an acute angle. Okay, let's see. So simply we can observe the diagram and write. So that will be here as a given. What is here? So O is the center. O is the center of a circle. So this is written. Then segment RS. Segment RS is a diameter. See, it's written. And point which it is. So that we are going to write point T is a exterior. Point T is a exterior point. So exterior point of a circle. Here we can write it. Then we have to prove. That is to prove. What is to prove? So let's see. They said angle RTS. So see that what we have to prove. So obviously we come to know it has to be joined. So we'll write it. Angle RTS is an, what it is? It's a acute angle. RTS is an acute angle. So we immediately, to prove only guide us. What? If you want to solve this, so obviously first you have to do the construction. What is that? So simply you can join the point, that is RT, and as well as which it is TS. You can join the point RT and TS, and one more thing, on the circumference take one more point, which suppose P point will take, and that also we will join. So listen here, this all part which is mentioned with the dotted, it is a part of the construction. Means the construction clue we get from the to prove. To prove they said show angle RTS is an acute angle. So RTS means RTS. This is the RTS angle. If you want to show this is acute, so obviously we have to join. So we joined also, and one more construction is done. We took the point P on the circumference, and then that point also joined to the S point. So next one topic here we'll write, it's a construction. So in construction what we are going to join, what we are going to write? So here join the segment which it is, it's a RT, then TS, and take a point, we'll write it. Here we'll write. Take a point, which point we took? P on circumference. Here we'll write it. Here it is. On a circumference. And join to whom it is? Point S. And we have to join to the point S it is. Just it is like this. This is the construction is done. And now after that we can discuss the proof. Okay, what is the proof? Look at here now. RS is the diameter. We'll write this segment RS is a diameter. If it is a diameter, already it is given. So what is going to happen? We know that angle in a semicircular arc is what? So that is 90 degree. We'll write it. Therefore, angle RPS. Angle RPS is equals to 90 degree. This is first right here angle in here, which it is. So it's a semicircular arc. Angle in a semicircular arc, which is the 90 degree, that we know now. Now we can start. So let's see here angle, which angle RPS is, and see first concept we applied diameter. With the help of the diameter we prove angle RPS is what? So it is a right angle because it is angle in a semicircular arc. Then later, now we are discussing the angle RPS is what? Is an exterior. So it is an exterior angle of our triangle. The next one, which is the triangle? So triangle PTS. We said RPS is the exterior of a triangle, that is which? PTS. So immediately we know that the property of a exterior angle, always if we see the exterior angle is greater than to the whom it is, so it's remote interior. So we can write it, therefore angle RPS is greater than, angle RPS which is greater than to whom it is, so that is the angle PTS. This is the second, write it here, it's a property, we'll write it here, this is the property of which it is angle, exterior angle theorem. Okay, we studied exterior angle property that always the measure of exterior angle is greater than to its remote interior. Now let's see, angle RTS is the 90 degree, is written 90 degree. So 90 degree which is greater than to the angle PTS. Look at here. So obviously PTS is what? Is less than 90 degree. 90 degree is na RTS. So angle which is less than 90 degree, they are known as an acute angle. So therefore we can write, therefore angle P at angle PTS is an, it's a acute angle. For it we will write, this is the third one, right, it is from second, and now here it is third, I'll write it, it is from second. See in the second this is third, and here it is the fourth one. What we realize, what we come to know, first we showed semicircular arc, then angle, the next one we applied the exterior angle concept, so which was the angle in a semicircular, that is only the what, a right angle, here we come to know, and it is the exterior angle. So angle that is RPS is greater than to the angle PTS we come to know. Then angle RPS is of 90 degree, so it shown 90 degrees greater than to angle PTS. So PTS means here. So let's see. So we know general that definition, angle whose measure is less than 90 degree is known as an acute angle. Angle whose measure is more than 90 is known as obtuse angle. So that's why angle PTS is an acute angle, and this was only our proof. We have to prove that this angle will be an acute. Important maybe it can be occur for how many? 3 marks. So pay attentive and solve this one. After this we will see next question, that is question number 5 now. Mostly I am solving this all questions here, I will try to do it. So in question number 5 you will see here, what is that? They said it's also 2 marks question now, the question number 5 we are solving. We have to take any quadrilateral, and in that prove that any rectangle is a cyclic quadrilateral. Simple 2 marks prove important Let's see question number 5 we are doing they said what? Here prove that any rectangle, chalo theek rectangle is required, then we'll construct here. I am writing the solution for it. So take this rectangle, write the name, suppose this is A, B, C and D. rectangle to opposite sides are equal and parallel, that is mentioned. Each angle is how much here? So that is 90 degree. So write it given, here will write given what? The quadrilateral ABCD is here a rectangle, here is written. Then to prove, here will write, what is to prove? That quadrilateral ABCD is a cyclic quadrilateral, this we have to prove. And then we can start the proof, no need of what? Any kinds of construction, because we have to see. Simple thing it is, quadrilateral ABCD is a rectangle. Here we guess, any you can take, this is the given. So start to apply its property. Sides to opposite, parallel and congruent, angles will use it. So let's see, the measure of angle A which is equals to measure of angle B which is equals to measure of angle C, and also it is equals to measure of angle D which is equals to 90 degree. This is the first one. The reason is here, this is what? Each angle of a rectangle. Each angle of a rectangle is a right angle. And then we will apply with this property, continue. Take any opposite pair and substitute value. So therefore here angle will write up. Here we mention angle A also 90, angle B also 90, angle C also 90, and D also. So adjacent also option A vertically, but we require vertically, opposite, because there only we explained in the previous part कि opposite angles of cyclic quadrilateral are what? That is supplementary. So here we will take the pair, therefore angle A, I'll write it, measure of angle A plus measure of angle which it is C, which is equals to, this will be 90 degree plus 90 degree, right? It is from what? 1 it is. So 90 plus 90 means how much we are going to get? It's a 180 degree. So angle A plus angle C 180. Similarly you can prove angle B plus angle D also 180. And then here we can mention measure of angle B plus measure of angle D which is equals to 90 plus 90 which is equals to 180. It's also from 1, and therefore here we can say quadrilateral which it is ABCD is a, here what? It's a rectangle. And this is the statement number 2, here it is statement number 3, this is statement number 4. The reason, total here 2 marks hai, so your half mark is pending for this reason. It's a what? This is the converse of cyclic quadrilateral. Cyclic quadrilateral. Just we discussed कि if you have any quadrilateral, and in this quadrilateral if opposite pairs are supplementary, then that quadrilateral is known as a cyclic quadrilateral. I hope today's session whatever we discussed, that is the practice practice set, ये 3.4 का question number 2 to still 5 we completed, you understood well, and in it summary wise, so which concept here we use. So in the short here I'll say what was the summary. So we applied which theorem? So that is inscribed angle. Here I'll write it. This is the inscribed angle theorem. Always it is half to the intercepted arc. Intercepted arc I'll write it. That one concept. The second we apply opposite angles. Opposite angles of a cyclic quadrilateral. They are supplementary. So this concept also we applied. So in this equation, so you have to revise these theorems and get it prepared for the SSC boards examination also, because that it was the, after that your 3.5 is omitted, then later that means after this exercise the remaining parties of this lesson is omitted. So we have to pay attention for these theorems and as well as the examples also. In the next session I'll continue remaining 3 examples, that is also important for you. So thank you very much.